Alright, this is the third video on simplifying radicals, and in this video we're going to learn how to rationalize a denominator. Whenever we're simplifying radicals, we can't have a radical in the denominator of a fraction, so we need to get rid of it. So to get rid of that square root of 5 in the denominator, I can multiply it by the square root of 5. And what this does is that gives me the square root of 25, which is 5. So we don't have a radical in the denominator. But if I multiply the denominator by the square root of 5, I have to also multiply the numerator by the square root of 5. So now I have square root of 3 times square root of 5 is the square root of 15 over, and then here I'm not going to write out square root of 25 in the denominator, but just so you know, the square root of 5 times the square root of 5, that is equal to the square root of 25, and the square root of 25 is 5. So here I have the square root of 15 over 5. Alright, let's take a look at this one. I have 2 over the cube root, I have 3 over the cube root of 2. So I need to get rid of the radical in denominator. So what can I multiply the cube root of 2 by to get rid of the radical? Well, I need to multiply the 2 by something that gives me a perfect cube. Well, the closest perfect cube to 2 is 8, because the cube root of 8 is 2. 8's a perfect cube root. So what do I need to multiply to 2 to get 8? Well, that's 4. 2 times 4 would give me 8, and the cube root of 8 is 2. So now I have to also multiply the numerator by the cube root of 4. So this gives me 3 times the cube root of 4 over, and I'm going to go ahead and write this out, the cube root of 8, which equals 3 times the cube root of 4 over, and then the cube root of 8 is 2. Alright, let's look at another one. I have the square root of x cubed over y to the 5th. So the first thing I'm going to do is I'm going to split up the fraction. So that's going to be the square root of x cubed over the square root of y to the 5th. Now what I'm going to do is I'm going to simplify the numerator and denominator. See, x cubed has a perfect square root in it, and y to the 5th has a perfect square root in it. If you need to see how to simplify the square root of x cubed and the square root of y to the 5th, you can watch the second video, and I'll go over that in the second video. So the square root of x cubed, I can rewrite x cubed as x squared times x over, and then y to the 5th, I can write that as y to the 4th times y. So this gives me the square root of x squared is x. This x here, it stays under the radical because it's not a perfect square. So times the square root of x over, and then the square root of y to the 4th is y squared. Y is not a perfect square root, so it stays under the radical. Now I need to get rid of the radical in the denominator because I'm finished simplifying the numerator and simplifying the denominator. So to get rid of the radical, what can I multiply the square root of y by to get rid of the square root? Well, I can multiply that by the square root of y. So that's going to give me x times the square root, and x times y is xy over y squared, and then the square root of y times square root of y is just y. So that gives me x times the square root of xy over, and y squared times y is y cubed. Alright, let's look at number 4. Okay, I'm going to split this up. I have the cube root of x over the cube root of y. Now I need to rationalize the denominator. So what can I multiply to y so I'll have a perfect cube? Well, y to the first times y squared. Okay, so let's multiply by the cube root of y squared in the denominator, and then that means I have to multiply by the cube root of y squared in the numerator. So you can see that this gives me the cube root of x y squared. See, x times y squared is xy squared over, and then y times y squared is y cubed, and that's the cube root of that. Okay, so now I have the cube root of x y squared over, and then the cube root of y cubed is just y. And there's my answer. Now let's look at this one. Okay, I need to get rid of the radical in the denominator. Well, notice we have 4 minus square root of 3. It's not like the ones we've worked previously. See, we've just had, like here, we've just had a 1 square root. We've just had 1 radical. And same thing here, we've just had a radical in the denominator, a single radical. There's no plus or minus. But here we have 4 minus the square root of 3. So the way that I get rid of the radical is I multiply the numerator and denominator by the conjugate of the denominator. And the conjugate, what you do is you change the sign in the middle. So this is going to be 4 plus the square root of 3. Okay, that's the conjugate of the denominator. So that means I have to multiply the numerator by 4 plus square root of 3 also. So now I have 2 plus square root of 3 times 4 plus square root of 3 over 4 minus square root of 3 times 4 plus square root of 3. And this is going to equal, so when I multiply this, I use the FOIL method. You can watch one of my other videos, operations on radicals, and I explain that more in that video. So here I have 2 times 4 is 8, 2 square root of 3, 2 times square root of 3 is 2 square roots of 3, plus square root of 3 times 4, 4 square root of 3, plus, and then square root of 3 times square root of 3 is just 3. And that's over. Now this, notice the form that this is in. This is a minus b times a plus b. So this is just a squared minus b squared. And in this case, a is 4, b is square root of 3. So this is 4 squared minus square root of 3 squared. So now I have 8 plus 3 is 11 plus 2 square root of 3 plus 4 square root of 3. That's going to be 6 square root of 3. And also in that video, operations on radicals, you can watch that on how to add radicals. And then here I have 4 squared is 16 minus square root of 3 squared is 3. So my final answer is 11 plus 6 square root of 3 over 3. And there's my final answer. And that's all on simplifying radicals.